All right, for those of you who have their headphones on, can I get a thumbs up? Can you hear me? Fantastic. All right, we're going to get started. If you have any technical issues, please wave down someone up front, or just kind of put your hand up if you have any technical issues. With that, so let's get started. So we have only 20 minutes to get through this, but today's session is about learning to program, not write prompts with DSPy. We're going to use a restaurant example to kind of articulate how you're going to use DSPy to declaratively program your GenAI applications, and we'll go through an example of that as well. But first, our forward-looking statement. You're going to see this a lot, so I'm not going to read through this. And a little bit about myself. I'm a delivery solutions architect from Databricks. I work in startups and emerging enterprises from Los Angeles, and I have a huge interest in my cats and video games. So, fun facts. So, all that to say, as we all know, and as you've probably interfaced with like ChatGPT, Claude, and so forth, writing prompts is extremely tedious and very unsustainable, right? You don't want to be managing an entire block of text, which I'm sure some of you have already tried to do, to get your large language model to do exactly what you want it to do. So it's also hard to identify where in that prompt something is going wrong, right? It could be this portion of your text, it could be this portion of your text, who knows? But all that to say, you're ultimately just doing this by trial and error, right? If you were writing a system prompt for like your other framework, I'm not gonna name drop, but, and you're trying to figure out which system prompt works the best, you're doing no shot, few shots, self-consistency, all these different prompt strategies, and you're just trying to figure out if it works. That's not also good practice. And this is also incredibly difficult to modularize, right? You have to maintain essentially a library of prompts that you're going to send to your different applications, but at the end of the day, it's still text, right? Like, what are you going to do with text? So, all that to say, that's why we're here to talk about DSPy. DSPy 3.0 will be announced. There's a DSPy 3.0 session tomorrow from the creator of DSPy himself. So if you want to learn more about DSPy 3, please register for that session. But I'm not going to cover that. We're just going to walk you through on how to use DSPy to then program your GenAI application. So, what is DSPy? Omar, sorry if I can't pronounce his last name still, but Omar Khattab, he's the one who created it, came out of Stanford. He was under Mate, our CTO, and a lot of his inspiration comes from PyTorch and neural network abstractions. So as you look through the DSPy examples, you'll actually start to see some familiar patterns from those frameworks within DSPy. It's a declarative framework. A lot of people first used to use DSPy before structured output came out from OpenAI, but ultimately it uses typing, it uses reusable modules to develop and code large language model abstractions that you understand instead of manual strings. And you can iterate much more quickly with that structured code instead of, again, blocks of text that we've all probably have worked with at some point in your development. It's lightweight and future-proof. And what I mean by that is that it's pure Python. You're not here waiting for an integration to come out for your particular framework. It's designed to accept really any Python library that you want to use. You don't have to wait till that library is compatible with whatever framework-specific typing that comes out. It's lightweight. There's not a lot of different dependencies, which is probably music to some Python developers' ears, and it's very reproducible. Okay, so all that to say, let's look at some code and stop looking at slides. But it's really as simple as defining a class. So the first thing here, if you can see the laser, no? Okay, I'm going to try and point to it. But this first line right here is you actually setting the large language model itself, right? You don't have to change anything else if you want to use any other provider. You just change it to like Bedrock / whatever your model provider is, and the rest of your DSPy code will work because in the backend it uses light LLM that handles all that conversion for you. So again, if you don't want to use Databricks, you can use OpenAI, you can use Anthropic, you can use whatever, and you don't have to change or install any other packages. You just need to change that line, and you'll be able to use that new model. this right here, this class, is essentially what would be your prompt, but you're defining a signature that's describing how you want the model to accomplish the task. So for this one, we're trying to classify emotions, and I'm expecting a specific input called sentence, which I want it to be a string. And the outputs that I want is a literal with these strings. So DSPy knows to take this and enforce the input to be a string and the output to be one of these emotions. So, and then if I need to run it, there's these last three: the actual input, the sentence itself. This is us assigning it to a pre-built module, DSPy.predict. DSPy.predict is one of the pre-built ones to actually just interact with the large language model. And then finally, you run classify sentence equals sentence. The output is, I didn't put it up here, but the output will then come out to be your sadness, joy, love, whatever the case might be. And you can use the output like classify.sentiment to access the value that came out. So all this to say, to help you better visualize and understand how to develop something with DSPy, we're going to think of this as a restaurant. It's like taking a recipe and then giving it to your cooks to create a brand new dish. So you're trying to define your ingredients, like you saw with that DSPy signature. You're trying to define what your inputs are and what the final dish is supposed to be, right? What's the final output? And then you got to define your goal so that you know what the class is supposed to do. Try them out together, figure out what you want to do with it, and then discover your new dish. So you'll be using DSPy signatures, as you saw a preview of in that first code snippet. That's your recipe on how you want the large language model to handle that use case. And then the module itself, there's pre-built one, like I said, but you are also allowed, or DSPy lets you build your own DSPy module, which you'll see in my later session at 4 p.m. if you want to join that one, where it's a much more detailed version on how to do that. But you can actually just create it by initializing and then having a predict method to put not only different modules together, but your own Python logic. You don't have to use only DSPy code. You can use mostly Python code and then call it DSPy.predict to complete everything, right? So you do some ETL first or something like that. So these are just some example modules out there, but there's still new ones coming out. DSPy 3.0 has a few more coming out as well, but these are the main ones that you can use. And for those of you in the back who can't see, there's predict, chain of thought, react, and best of n. React is what you would use for agents. So if you are familiar with function calling, there's the reasoning and the action part, and that's kind of what that enables for your language models. Okay, so let's go through the step-by-step process that we talked about earlier. Your first step is to define the ingredients. So your ingredient is, what model are you going to use? What are you going to use for this classification? What do you want to use for this classification task? So like I said earlier, you can define any multiple configurations from any provider, and then you can also interchange them depending on the module, right? If you have a very specific very specific signature that's only doing text extraction, maybe use Llama 8 billion. Or if you have a image classifier and you need to use a multimodal model, then you should maybe configure Anthropic Claude 4 and then use that for that part, and you can use that all in one DSPy program. Okay, so I kind of went over this. Step 2 is defining your goal and your end dish. So let's go back to this example. What were we trying to do? We're trying to classify an emotion within some kind of string text, right? So we need to use the DSPy signature to actually declare the inputs and outputs of it so that we know what we're looking for and we know what the inputs are and what the outputs are. So you have to make any kind of typing that is in the typing library, essentially, you can use. It could be a Boolean, it can be an integer, it can be a float, but just keep that in mind. And if you want to use custom typing, you can always use Pydantic. Base type also came out in DSPy 3.0, where if you're familiar with Pydantic base model, it's pretty much the exact same thing. But you can create your own like that and pass that in as a type. So that way you can also do some data validation before you put in an input or get an output. So one thing that I haven't really mentioned is the iteration step of this, right? So especially when developing generative AI applications, you want to go through, you want to iterate quickly. You want to make sure what you had created and the model that you're using is performing up to the task, right? So it's really, all you need to do is pass it into something as simple as this. But if you feel like the predict is actually not working too great, but you want to use this large language model, maybe consider using chain of thought. If you don't know what chain of thought is, please Google it. I don't have time to talk about that, but you probably know what it is. But chain of thought does help, gives it some extra steps, extra reasoning to help with that particular use case. So you can go through some other modules very quickly in order to accomplish that use case. Okay, so kind of covered all this. And we'll keep iterating. So here's another example. So here's another example where maybe you've decided, okay, I actually don't like that large language model's performance. I'm actually going to switch it to OpenAI's GPT 4.1. I'll just reconfigure it to that model, and I don't have to change anything else. You see, the class is pretty much the same thing, and you can just keep iterating it over and over again with minimal code change to really understand what's impacting your GenAI application the most. So once you're satisfied, you can use Databricks' MLflow integration, DSPy.autolog to do MLflow tracing. You can also do, and then you can register it, log it, deploy it, all on Databricks, of course. That's going to be the pitch. But you would use MLflow to kind of track different versions of your agents, make sure that you can do governance on it through Unity Catalog, and use the infrastructure Databricks provides on the model serving infrastructure to actually deploy it. So this is simple. I don't have the actual deployment code in here, but this is just to get it into Unity Catalog. So altogether, this is what the entire code looks like. So with the first step, again, let's just to kind of like walk it back. The first one is we define what model we want to use, and then we define the signature itself right here to understand how we want the large language model to accomplish the task that we're defining. Then we do a quick test, maybe do another test. Maybe we want a stronger large language model, or maybe, if I think there was like a new Quen model that came out like a few days ago. You want to test that one? Just change this, and then you can change it, and then it will work against this same signature. So, and then when you really like it, you can use it way down below here. So that's really it. Now you know how to use DSPy. That's all you need to do in order to start using this framework. You don't need to know any other classes. You don't need to know any other functions. That's really the core of how you would use DSPy. And if you want to see a more advanced or other features of DSPy, there's a 3.0 session tomorrow, and then there's my session, the multi-agent session, at 4 o'clock later today. So please join the community. Omar is very active. I've never seen a creator so active on his Discord, but he's literally replying to every single person. So feel free to join us on Discord, contribute to the repo, and this is the official documentation on the left right here. So that's it. We got 6 minutes left, so if there's any questions, I will have to come up to you and repeat your questions. So if you have any questions, raise your hand. But otherwise, that concludes the session. Thanks all.